In this video, I'd like to show you a fun and historically important example of neural network learning, of using a neural network for autonomous driving, that is, getting a car to learn to drive itself. The video that I'll show in a minute was something that I've gotten from Dean Pomeroy, who's a colleague who works out in Carnegie Mellon University out on the East Coast of the United States. And in part of the video, you see visualizations like this, and I want to tell you what the visualization looks like before starting the video. Down here on the lower left is the view seen by the car of what's in front of it. And so here, you kind of see a road that's maybe going a bit to the left and then going a little bit to the right. And up here on top, this first horizontal bar shows the direction selected by the human driver and is the location of this bright white band that shows the steering direction selected by the human driver, where here far to the left corresponds to steering hard left, here corresponds to steering hard to the right, and so this location, which is a little bit to the left, a little bit left of center, means that the human driver at this point was steering slightly to the left. And this second bar here corresponds to the steering direction selected by the learning algorithm. And again, the location of this sort of white band means the neural network was here selecting a steering direction that's slightly to the left. And in fact, before the neural network starts learning, initially you see that the network outputs a gray band, like a uniform gray band throughout this region. And so the uniform gray fuzz corresponds to the neural network having been randomly initialized and initially having no idea how to drive the car, or initially having no idea what direction to steer in. And it's only after it's learned for a while that it will then start to output like a solid white band in just a small part of the region corresponding to choosing a particular steering direction. And that corresponds to when the neural network becomes more confident in selecting a band in one particular location rather than outputting a sort of light gray fuzz, but instead outputting a white band that's more confidently selecting one steering direction.
Alvin is a system of artificial neural networks that learns to steer by watching a person drive. Alvin is designed to control the NavLab 2, a modified Army Humvee equipped with sensors, computers, and actuators for autonomous navigation experiments. The initial step in configuring Alvin is training a network to steer. During training, a person drives the vehicle while Alvin watches. Once every 2 seconds, Alvin digitizes a video image of the road ahead and records the person's steering direction. This training image is reduced in resolution to 30 by 32 pixels and provided as input to Alvin's 3-layered network. Using the backpropagation learning algorithm, Alvin is trained to output the same steering direction as the human driver for that image. Initially, the network steering response is random. After about 2 minutes of training, the network learns to accurately imitate the steering reactions of the human driver. This same training procedure is repeated for other road types. After the networks have been trained, the operator pushes the run switch and Alvin begins driving. 12 times per second, Alvin digitizes an image and feeds it to its neural networks. Each network, running in parallel, produces a steering direction and a measure of its confidence in its response. The steering direction from the most confident network, in this case the network trained for the one-lane road, is used to control the vehicle. Suddenly, an intersection appears ahead of the vehicle. As the vehicle approaches the intersection, the confidence of the one-lane network decreases. As it crosses the intersection and the two-lane road ahead comes into view, the confidence of the two-lane network rises. When its confidence rises, the two-lane network is selected to steer, safely guiding the vehicle into its lane on the two-lane road.
So that was autonomous driving using a neural network. Of course, there are more recently more modern attempts to do autonomous driving. There are a few projects in the US and Europe and so on that are giving more robust driving controllers than this. But I think it's still pretty remarkable and pretty amazing how a simple neural network trained with backpropagation can, actually learn to drive a car somewhat well.